Welcome to another video lesson on workshop processes. My name is Engineer Garwaji Julius. Today I'll be talking on drilling and the reaming, two very important processes in the workshop, especially in the fitting shop. Many a times there will be need for one to actually create a hole where one may likely need to fit a particular component. The creation of a hole from the beginning through the use of another tool called drill is called drilling. So drilling in itself is a metal cutting process that is carried out by a rotating cutting tool that decides to make a circular hole in a solid material. The hole may be a thorough hole or it may be a blind hole, a true hole or a blind hole. These are the two categories of hole that one may decide to create. Drills are the tools we use to cut away fine shavings of material in a rotating manner through the material in order to make a hole. So tools that we use is we call them drill bits or twist drill, depending on the configuration of the tool. But the most common of them is the twist drill. From the image I'm showing on the screen, there is an illustration of a true hole and a blind hole through the application of twist drill. From the expression on the screen, we can see that the point angle on the drill is very important in order to initiate the starting point for the drilling process. The two pictures reveal a true hole and a blind hole. But we cannot actually accomplish the process of drilling without the use of a drilling machine. And that is why drilling cannot take place without drilling machine. Drilling machine is a mechanical machine that has been designed to actually generate a rotating motion after the drill bit has been installed in the spindle of the drilling machine. The drilling machine with the rotating effect will feed the cutter into the work to be drilled, and this is a process of drilling. There are several types of drilling machines that are available. The commonest one of them all is the pillar drilling machine, and of course there are other types like the bench drill. We equally have the radial hand drilling machine, and of course there is gang drilling machine and the multiple drilling machine. But in most workshops these days, we have the common types: bench drilling machines, pillar drilling machines, and of course, the radial drilling machine. These three types of machines are readily available in most workshops because most of the jobs that we do in drilling, we can readily apply the three types: the bench drill, the pillar drill, and the radial hand drilling machine. The illustration I'm projecting on the screen illustrates a typical bench drill with the housing of the head. The head houses the pulley with the incorporation of the belt drive, and of course on the head we equally have the motor that is providing the rotating motion that drives the machine. Electric motor is housed on the head of the machine. Equally, we have the operating lever attached to the head of the drilling machine. And of course, the drill chuck is mounted to the spindle of the drilling machine. The essence of the chuck is to hold the drill bit that will be fed into the workpiece. And by the middle of the pillar, we have the table. The table is the one that carries the vice upon which we actually mount the work to be drilled. And the base is a robust base that is mounted on a very solid support to provide rigidity and stability for the machine. So drilling machine is a very important machine in every workshop because most of the work we work upon, we must have one reason or the other to drill one component or another in order to create proper fitting. And of course, I did mention another type of drilling machine that we call radial arm drilling machine. Radial arm drilling machine has more capacity to drill than the very first two, than the bench drill and the pillar drill. Why this is having more capacity is because the radial arm drilling machine has the capacity to stretch its arm to drill without necessarily shifting the position of the work. The arm of the machine can move up to 180 degrees in order to drill at every point within that radius of the arm. So, and of course, the position, the head of the machine can equally move transversely on the arm. This gives this particular machine the capability to drill a very large workpiece without necessarily shifting the mounting of the work. And this is a very good advantage using a radial arm drilling machine. It can accommodate very large work that we don't need to be shifting the job here and there before we actually do the drilling. It is a very important drilling machine that every working workshop should equally have. And what are the necessary parts that are available on this machine? As labeled, and as you can see this in my slide, you see the very first one is the base. The label number 2 is the column, while the label number 3 is the radial arm. The number 4 label is the motor for elevating the arm. The arm has the capacity to move up and down, while it equally has the capacity to rotate along the radius of the arm. It has the capacity to move. And of course, we have the elevating screw, which is the number 5 on the sketch. The elevating screw that can drive the arm up, down. Number 6 is the guide way. The guide way upon which the head of the machine can move to fro. It can move back forth along this rail, while the motor for driving the spindle is equally attached. The motor is the one that is providing the rotary motion for the spindle of the machine. So this machine, with its capacity and the capability, is very good for heavy and larger work, and of course is inevitable in every fitting workshop. The drill in itself, which is the tool that we use to actually provide the needed drilling into the material, is very key. And of course, we have 3 different types of drill. We have the flat drill, we equally have the straight fluted drill, and there is another drill that is called the twist drill. The 3 of them are very, very important, and they have different areas of application for each and every one of them. So for the twist drill, it is important for one to note that the cutting angle of the twist drill must be of 118 degrees. 118 degrees. The addition of this 118, this is 59 degrees and 59 degrees. Altogether, we have 118 degrees. So the cutting angle of a twist drill should provide 118 degrees to obtain a correct diameter of the hole. If the angle is having an issue, then we are not going to have a thorough hole. A proper concentric hole cannot be formed. So in a situation whereby the angle is being affected, it is normal for the user to first and foremost grind the tool to the required angle, cutting angle of 118 degrees. And it should be ground properly. Grinding of this particular tool require proper skill. It is not everybody that can grind tool to size. It's something that one develop over time through experience, through constant practice. So, and what are the materials of this drill? A very good drill should be made from high-speed steel. High-speed steel. And for special metals, probably metals that are hard in nature, there may be need for one to go for extra strength drill. A very good example of this is the HSS alloy steel of cobalt series. HSS alloy steel of cobalt series. HSS high speed steel alloy of cobalt series. This gives additional strength to the capability of a drill to drill very high material. So in every drill, flutes are incorporated. The flute is the spiral passage on the drill to give opportunity for the chips of the material that is being cut to pass through. When the drill is going into the material that is being cut, there must be passage for this material to come out. So the spiral passage that is created on every drill allow this spiral groove, allow the chips to move around the drill and begin to come out as the drill penetrates the material it is being cut. A very good example of this is shown on the screen. It's a situation whereby we have the spiral flutes. The flutes are spiral in nature. They can accommodate the chips that are being produced in the course of the drilling. They begin to come out through this spiral configuration on the drill. And if we are to look at the entire configuration of the drill, there is the body that is doing the drilling, and there is the shank, which is the tail that enters the chuck or that enters the drill chuck. There is always a recess after the body. The recess is to provide opportunity, to provide a gap between the body of the drill and the shank. And of course, you can see here we have the land, which is this very structure at the tip of the by the corner of the spiral orientation of the drill. Each of them has a cutting blade. As the drill rotates, they equally provide the finishing touch through the circumference of the hole they are creating. So that is the configuration of a twist drill. A twist drill, as I said, is the most common one. There are other drills like the taper shank, like the parallel shank, but the twist drill is the most common. The clearance that I said should be created is illustrated on the screen. 180 degree clearance of cutting angle, which is very important. Any deviation from this is not normal, and of course it's not going to provide a normal hole in the course of the drilling. There are special types of drill that are equally important apart from the common one that we mentioned. This special type of drill provide opportunity for one to make provision for special holes. Special holes, an example of this is a sports drill. Sports drill type of hole, which illustrates opportunity for one to have special bolts. This provides an opportunity for both head to sit perfectly in this groove. So, and it is only through special drill that we can have this, because this smaller diameter will have been created by a smaller drill. Then later we expand the head by another drill that is called counterbore drill. Another special drill that is called counterbore drill. Counterbore drill is the one that can provide it. It expands the originally drilled hole to this configuration for the purpose of providing seating for the bolt or whatever type of screw that is coming into this profile. So an example of a counterbore drill is illustrated in my slide as shown on the screen. A counterbore has a pilot head that actually provides the pilot into the hole. Another type of special drill that is available is a countersink. Countersink provides a conical seat. Instead of this perfect cylindrical seat, a countersink will provide a conical seat for the head of a screw of this configuration, so that it can actually come into the hole and then align with the surface of the object. That is an example of a countersink hole that could be provided by a countersink drill. A countersink drill is another type of a special drill that is equally of very relevant in the fitting workshop. And of course, most of the time when the fitting job is to be done that require screwing or bolting down, there may be need for one to have this kind of a sitting. Then we cannot use ordinary twist drill to get this done, except the special drill that is called the countersink drill, as illustrated in my slide. Then what does the process of drilling involve? For anybody to carry out the process of drilling successfully, one must be able to first and foremost identify the type of drilling machine to be used for that particular job. And while one is selecting that type of drilling machine, what is the capacity of the job to be drilled? Is it the one that a normal bench drilling machine will be able to accommodate, or I need to make use of a pillar drilling machine, or the work is bigger enough for me to drill it on the radial drilling machine? Having selected my drilling machine, then I need to know that where do I actually clamp my work on the drilling machine. I need to provide a very good vise that will provide firm clamp of the work for me on the table of the drilling machine. After securing the work, I must be able to locate a particular point, the starting point for the drill on the job. I must be able to do this through the help of a dot punch to create the starting point for the job to be drilled. Then I should be able to align the axis of my drill with the job. The axis of the drill bit that is to do the cut, I must be able to align the axis, the tip of the cutter, the drill, with the cutting point, the cutting position where the hole is to be drilled. I must be able to align the axis, that is, centering the axis of the drill with the center point that has been actually marked for the starting point for the hole. I must be able to center my drill bit. Having done this, then I will start the machine and begin to feed my drill gradually into the work. There are instances whereby the drilling process will require some level of cooling. If the work is a hard type that require cooling, then coolant must be added in order to prolong the life of the cutter, and at the same time to lower the amount of heat generation from the drilling process. So when the drill bit touches the work, the drill bit starts revolving into the material on a gradual basis, depending on the level of feed that is being sent by the operator of the machine. The practical activities of this will be carried out in our workshop practice, and by the time we are going to be having our practical exercise. But drilling is a very interesting exercise to be carried out in the workshop. So what are the other operations that one can perform on a drilling machine apart from the regular drilling? One can carry out boring operation on a drilling machine. A situation whereby an existing hole or a hole is just being drilled and I need to expand the hole, I can bore already drilled hole further. Already drilled hole, I can bore it further. That is, boring is a process of expanding an existing hole. Process of expanding an existing hole. This is possible on the drilling machine. I can expand an existing hole through boring on the drilling machine. This will be expanded further to a larger diameter. It will be expanded further through a larger diameter through the use of a bigger drill bit or another tube. Another operation that could be carried out on the drilling machine is the counter boring, as I explained earlier. We can counter bore an existing hole, or we can counter sink an existing hole. In the case of counter sinking, we are trying to provide a conical hollow space at the top of the existing hole. And of course, we can equally carry out spot facing. Spot facing is a way of providing a flat surface on a job by way of making use of a spot face drill. We can make use of that to provide flat surface on a job. And on a final note, we can equally carry out tapping. Tapping operation is the process of forming thread on a simple workpiece, forming thread. This is possible. We can form thread with the use of a drilling machine by the time we make use of our tap. We make use of our tap that has been mounted on the drill machine. We drive it gradually into the workpiece. A mounted tab can create thread in an existing hole. These are part of the processes and exercises that we will carry out practically in the workshop. And of course, drilling machine can equally go a step further by way of performing reaming operation. What is reaming operation? Reaming operation is a process of finishing up a drilled hole in order to get the actual size, the required size. In most cases, drilling may not necessarily give us 100% normal size. If I'm to drill a hole of 20 mm diameter using a normal drill, it's possible I won't get exact 20, but with the use of reaming, I can decide to use a drill of 19 to create the first hole, to create the hole. Then I go further to use reamer. The reamer will now finish it up to diameter 20. Having drilled with diameter 19 or 18, I can finish it up with the reamer to diameter 20 mm, which is going to be more exact than using a normal drill of diameter 20 mm size. Reaming is a process of finishing up an existing hole. The advantage of reaming is that it gives a more finished job. It corrects some form of out of roundness that one might have encountered in the process of drilling. So drilling is replaced. Some people can replace drill with reamer, where the speed in the process of drilling is reduced to half the size or speed we use for drilling. If we are decided to use 250 rev per minute, 250 revolution per minute for drilling, if I'm to ream the already drilled hole, I have to go. My speed must come down by half. That means I'm going to use a speed of 125 rev per minute to carry out reaming. So reaming doesn't really require high speed. I normally need to go half the speed of the speed that is used for drilling. So the essence of this is to actually achieve the very good finish that is intended to achieve in the course of reaming operation. As you can see from the slide that is being projected, the process of reaming involves making use of a reamer and drive the reamer into the workpiece for the purpose of perfecting an existing hole to the required normal size. It is a very good exercise. Every accurate job that must be well assembled must be properly reamed in order to create perfect fit that is needed for that job. Functions of reamer have highlighted that the reamer will control the diameter of the hole. It's going to give us an improved internal service of the hole, and of course it can correct out of roundness. Those are the errors that drilling must have actually imparted on the job, but the reaming operation will finish up and correct all these errors. There are three different types of reamers anyway. We have the hand reamer, there is the machine reamer, and of course there is the adjustable reamer. The three of them are practically possible to use in the fitting shop. I have equally mentioned the fact that tapping could be carried out with the use of drilling machine. Tapping is a process of creating internal thread in an existing hole. This is achievable with the use of drilling machine. Then, the mathematical parameters of a drilling machine. We mentioned cutting speed. We equally mentioned the feed. What is the cutting speed? The cutting speed is the various speed of the drill. The speed of the drill as the speed rotates. Then the feed is the rate at which the cutter, the drill, advances into the work. That is the feed. The rate at which the cutter, which is the drill bit, advances into the work is the cutting feed. Mathematically, it is expressed. The cutting speed is expressed as mathematically, the cutting speed is denoted with letter V and is expressed as pi dn. where N is the regular pipe, 3.142. D is the diameter of the drill, the diameter of the drill, the diameter of the drill. While N is the speed of rotation in revolution per minute. It is very possible for me to know the cutting speed, and it is very possible for me to determine the diameter of the drill that I'm to use if I want to go by a value of a particular cutting speed. So I can begin to manipulate these parameters in order for me to get whichever one I want to get. The depth of cut. How do I get the formula for the depth of cut? I need to change this to capital D, which represents the diameter of the drill. Depth of cut. The lower case letter D, depth of cut. Depth of cut is mathematically expressed as the diameter of the drill divided by 2, D over 2. That is the distance from the machine surface to the drill axis. And how do we get that? That is the diameter of the drill divided by the 2. Then for me to get the rate of material removal, that is material removal rate, MRR, material removal rate or rate of material removal. I need to know that is pi d squared over 4. Pi d squared over 4 times feet times n times feet times n. F is my feet, the rate at which I'm actually feeding the cutter, while n is my revolution per minute. With this, I can get my material removal rate. Then the machining time. How do I get my machining time? Machining time is capital letter T. Machining time. Machining time is talking about the length of the work to the drill divided by the feet and the rotation of the machine per minute. So we can get the machining time. That is, how long will it take me to finish this job? So everything will be calculated and predetermined in the even before one starts the job. So it is good for one to actually have a better understanding of this. With the understanding of this formula, we can manipulate. If I'm to do a particular job, and I'm having in mind by virtue of the material that I want to drill, I'm thinking of a particular cutting speed, then that cutting speed will guide me to selecting what size of the drill I'm going to use and what speed am I going to give to my machine to effect the drilling. Then let me go further by outlining the differences between drilling and reaming. The two of them are synonymous processes, but one comes before the other one. Of course, drilling will start before reaming. It is after drilling that one goes to ream a particular job. But we can equally look at it in this way. A drilling process will not give us a fine finished job, but a reaming process will give us a highly finished job. Reaming provides tight tolerance, and that's why I mentioned it the other time that a very good reamed job will provide proper assembled job, because then that one will guarantee tight tolerance job. Tight tolerance is not guaranteed in the work of drilling. So it is very important for one to know these differences. So these are the very few points that are very important for us to understand in drilling, but the practical exercise will actually expose us to other intricacies that are very necessary for one to know in the course of drilling. But we cannot round up this lesson without mentioning the safety aspect of it. Safety is key in all aspects of our job. What are the safety requirements for drilling? First and foremost, it is very important for every operator to know that the safety PPE, the PPE, personal protective equipment needed for drilling, is very important. The goggle must be worn to at least to guard against the flying chips from entering the eyes of the operator. And of course, the work to be drilled must be properly secured to the bench before the cutter is fed into the work. An appropriate cutting speed must be selected. Appropriate cutting speed must be selected. Use of cutting speed that is not suitable may actually cause the cutter to break, and this may be injurious to the operator of the machine. And cutting fluid may be necessary in some cases, except in the case of drilling a cast iron. One does not apply cutting fluid for drilling cast iron job, and one must actually take proper care when drill is nearly penetrating to a workpiece. It's getting to the head of the job. One must be careful in the way the feed is being, in the way the drill is being fed into the workpiece. One must be careful, and the screwing in action can lift up the workpiece. One needs to be very careful in the course of these two. So on the whole, we have learned several points in this lesson. We have looked at the essence of drilling machine, and we have equally looked at the different types of drills that are available, the different types of drilling machines that are equally available too, and what are the kind of operations that one can perform on the drilling machine, ranging from the normal drilling to reaming, to boring, to counter boring, counter sinking, tapping, and of course, the last but not the least, we can equally carry out tapping. I've mentioned that on the drilling machine. And of course, I have not forgotten to actually outline the safety requirements of drilling, which are key to every operator of a drilling machine. And in the course of the practical exercise, we want to believe all the users of the drilling machine will actually put into practice all these safety requirements. In the next video, we shall be talking on some methods of joining material together, which is still very key. Even after we have drilled, we are properly aligned, there may be need for one to assemble components together, and that gives the reason for us to have a clearer understanding of methods that are available for joining material together, not necessarily metal. We can join plastic, we can join other material. Till we meet in another class. Bye for now.